completed his mechanical engineering from College of Engineering, London, and then followed by PhD from IIT in Calcutta. He was specifically in first car project of Telco or Tata Motors, if I'm not wrong, around the year 1990 to 1992. Post that, he started his own entrepreneurship journey. He has been involved as an entrepreneur in the education space since 1996, where he co-founded Bullseye. He is also the co-founder and trustee of 3 schools which work under the Peepal Tree umbrella. Adding to that, he also serves on the board of IMOCA, which is a skill assessment company, which raised funding of roughly 100 crores in 2021. He is also associated with 14 trees and NGO involved in the reforestation and even the list of electrical vehicles since 2013. He works with Plug in India as a host YouTube channel. I think many more. Welcome, Mr. Gopal here for the talk, and we all look forward to his talk. Okay, question answer.
Sure, of course.
So, with his due permission, you can have your questions around it during the session.
Right.
But before we get started, put your mobile phone in the silent mode. That's the first and foremost step. Thank you.
Thank you. Okay, so please feel free to interrupt me wherever you want to. It's okay if we do not finish the presentation, right? But anytime you think there is a deeper discussion required, feel free to do that. Very quickly, I want to start with a little bit of what are your expectations from the session. So I talked to 2 people. Somebody talked about climate change, somebody talked about batteries, just to get an idea of what is there in your mind. Anybody else, what are you expecting from today's session?
How the change happened from IC ministry.
How will it happen? Okay, that's something which we will try to cover. Yes. Anything else? Yeah.
How the middle class families of India can afford the
How
the middle class families of India
can afford? Okay, I'll keep that in mind.
How the current constraints of electric vehicles like thermal management, because right now
Fires and all that. I have, yes. That's a good point. That's a very good point. Yes. Yeah.
how it can put carbon emissions.
How does it impact carbon emission? Okay, we'll kind of discuss that also. Anything else? Yeah.
Like, what are the different types of petrol
Safety related issues. Okay, we will try to cover that also. Yes. Anything else? Okay. So in case I have not covered, yeah.
And this is related to charging and some converter level things.
So I will talk a little bit about charging, but if I by mistake forget to cover any of your points, please remind me. I'll kind of definitely take care. Most of what you mentioned is something which I have planned to cover. Some of it, the specific numbers I may not be able to cover, but after the session gets over, I'm going to hang around for some time. Maybe we'll go outside this classroom because this is booked till after 4 o'clock. And I can spend another half an hour, 1 hour, vagara with any of you who is interested to kind of carry on this. Okay, I'm going to stay on the campus tonight. So I'm also going to be around tomorrow. So if there's anything that any of you are involved in a startup, is anyone over here who's kind of from the startup space? Okay, very nice. What are you building? Air taxis. Wow. Okay. The IIT Madras has a similar startup. Okay. I met with those people also. Okay. So let me start with a very basic introduction. Some of it you probably know, but still I'll assume that, you know, so your question was about conversion to electric vehicles, and, you know, so I have been an electric vehicle user from 2008. So my first scooter had lead acid batteries in it. I had to change them every 12 months, etc., etc. But I would say if you look at the graph of EV popularity, the last 2 years have been very significant, 1 to 2 years. And most of you will be able to guess why that has happened. Why do you think that has happened? Huh? Petrol prices, not Tesla. No. So technology and economics are kind of very interlinked with each other, right? And simply the economics of running an electric vehicle has become suddenly quite attractive thanks to higher prices of petrol, right? And although prices have come down a little bit, I think, but the long-term trend is clear in most people's mind that petrol prices will continue their northward journeys, right? And the other thing that is also interesting is CNG, because CNG is a cleaner alternative. And today, if you ask me, CNG prices are kind of comparable to electric in some of the spaces, right? But again, if you look at the price line of CNG, last 1 year has seen almost a 30-40% increase in CNG prices, right? So again, if you look at the trend line, you'll see CNG prices kind of, electricity prices will also go up with years, but you're definitely not looking at the same gradient, right? So by and large, when it comes to two-wheelers, when it comes to three-wheelers, right, definitely electric has an advantage today. When it comes to four-wheelers with fast charging, maybe not so much, right? Because fast charging gives you electricity at double the rate. So average rate of fast charging today is about 20 rupees a unit, right? And then depending on the efficiency of your vehicle, it could be anywhere between 150 to 200, 300 watt hours per kilometer. So that's how we kind of typically define the efficiency. It's not kilometers per liter, correct? So we will typically define the energy efficiency in terms of watt hours per kilometer, or let me put it this way. I have a Tigor electric at home, which we purchased about 2 months ago. And I get about 120 watt hours per kilometer. So roughly what it means in 1 unit of electricity, that all of you understand, right? 1 unit bijli ghar pe hum log kharidte hain. So you can run about 8 kilometers in 1 unit of electricity. So that's another way of looking at it. But watt hours per kilometer is better because I have a cycle which does about 10 watt hours per kilometer. I have a scooter which does about 20-25, right? And I have an E2O which does about 70-80. And I have a Tigor which does about 110-120, right? Depending on terrain, air conditioning, passenger load, etc., etc. All those variables go into the watt hours per kilometer calculation. But CNG today is kind of comparable, but long-term trends we are looking at EVs becoming more popular. Now, the other thing which is different about EVs is their maintenance, right? So practically, I can share this fact with you. The Mahindra E2O that my wife drives, we have owned it for about 8 to 9 years today, and we've done about 80,000 kilometers. If I look at the maintenance cost over 9 years now, it will be about 60-70,000 rupees, correct? Which is much, much less compared to any petrol or diesel or CNG vehicle. And the reason is very few moving parts. There is a motor, there's a little gearbox, that's it, right? So beyond that, there are no moving parts, and any engineering student will understand that it is these moving parts which cause more of maintenance problems, right? In an aircraft, for example, it is the engine which accounts for 80% of your maintenance cost. The remaining fuselage, flaps, vagara milke just hardly kind of contributes to anything, nothing very significant, right? So maintenance costs are definitely much better, and this is what makes it EVs quite attractive in the long term. And again, another thing which I'd like to mention as far as use case is concerned, that when I drove from Bombay to Shimla in a Tigor electric last month. So this was almost a 1500 kilometer journey. And one thing that strikes you, of course, you have to plan differently, because you have DC chargers which have been fitted by companies like Charge Zone and Tata Power and Xeon, right? But you have to kind of go to those chargers. They don't have the density of petrol pumps as of now, right? So you also need to change your behavior a little bit, because you and your car need to consume energy at the same time, right? So a lot of the good chargers are near food courts, correct? So you put your car for charging, you go and eat something, go to the washroom, etc., etc. And about, depending on how big your battery is, what is the kilowatt rating of the charger, anywhere between 45 minutes to 1.5 hours is what usually takes for a Nexon or a Tigor kind of car to charge. The bigger cars will take more time to charge. So today you have Kia has launched a new car, BYD has launched a new car. So all of these are with bigger batteries and better range. So they have almost 400-500 kilometers range, and they take more time to charge because these are 60, 70. The Jaguar has even got a 90 kWh battery pack, right? So all of these will kind of differ in terms of this thing, but by and large, that's about charging. And the second thing is the thing that we don't experience sitting in petrol vehicles is the lower vibration. So a lot of times you may think that this is very theoretical, that how does vibration really impact? But when you do a long drive on an electric vehicle, the fatigue is much less, right? So the absence of vibration is something which really kind of, so somebody who drives an electric vehicle would rarely come back to a normal vehicle after experiencing this kind of better quality of ride, right? And another thing, especially when it comes to well-designed cars, for example, the Nexon, which is India's top seller today, they're selling, or they're making about 4,000 vehicles per month now, electric, right? It's almost comparable to diesel now. And one of the things that makes the Nexon very popular is that it's got an underfloor battery. So those of you again who understand vehicle handling will appreciate the importance of a lower center of gravity, right? So a low CG means that the handling improves quite drastically, right? So Teslas also have the same kind of design. The Tigor, which I drive, doesn't have that. Unfortunately, it's got two battery packs, one in the dicky and one under the rear seat, right? So that's only a question of packaging. But any vehicles which are grounds up electric, Tigor and Nexon are not, by the way, right, will end up having designs which are bottom heavy, so to say, right? So move to the next slide. Please feel free to stop me anywhere, so if you want any kind of, yeah. The vehicle also has to have a certain ground clearance, right? क्योंकि अगर आप speed breaker पे जा रहे हो, या if you're going on bad roads, then you need a minimum height which you need to kind of have. So Tigor is not an SUV. Nexon is an SUV. So Nexon already had the advantage of higher height, so they could play around a little bit with the gaps over there. Tigor mein it will start touching this thing, and then the battery pack is safety all item, so you don't want that to kind of so that's one of the reasons why they could not do it for the Tigor. Okay, so this, I think somebody asked me this question. Just can we go back to the previous slide? Now before peach pehle wala. So do electric SUVs or electric vehicles, are they zero pollution? They are not, right? In fact, Tesla at one point of time attracted a pollution tax in Singapore, right? Because Teslas are not really, they made a great name for themselves, right? But they are actually in watt-hours per kilometer more polluting than most of the cars that Indian industry has to offer, right? So the reason is because the electricity that you buy in India today is 70% probability that is coming from a coal-fired plant, right? So reality is that you are not reducing pollution, you are transferring pollution, right? So you have pollution which is happening in the city today, and that is now going to your area wherever you are, Bhatinda power plant or any other power plant that is kind of being located. So in that sense, it's just a transfer of pollution. There will be a few people who have solar panels on their houses, who are kind of drawing electricity from those panels to charge a car. You could probably say that these guys are slightly better off. And then if you really want me to get into deeper, then the embedded energy of solar panels, etc. But I'll not get drawn into that discussion now, right? But rest assured that there is some amount of pollution that is created by electric vehicles, right? But by and large, if I were to compare a Nexon diesel versus a Nexon electric, then the energy consumption per kilometer is lesser, right? And also remember, petrol and diesel also have embedded energy in terms of the logistics, in terms of the extraction from the ground, etc., which we usually don't take into account, right? So almost 10 to 20% of your diesel or petrol has to be burnt only to extract that from the ground. So we don't really look at that kind of mathematics. So by and large, there is a favorable case for electric vehicles as far as energy is concerned, the CO2 is concerned, but it's not absolutely clean. I think let's be clear about that. Yeah.
Sir,
yeah.
if we include the manufacturing phase in emissions, then what will be
See, the only thing we need to look at is, we need to look at two things. One, when you're building the car, what kind of embedded energy is there inside? So let's compare apples and apples. You have an Exxon petrol and you have an Exxon electric, right? So you're looking at manufacturing the engine versus you're looking at manufacturing the motor and the battery pack. These are the two significant different things, right? So obviously a lot more embedded energy will go into the battery pack and the motor today, right? No doubt about that. But if I look at the fuel, correct, I would say that there is a reasonable amount of embedded energy inside the fuel, right, which we are not costing today, versus electricity where costs are more transparent.
One pool
Hmm.
to hold platform mine fee consume energy, transport fee consume energy, to drive that power plant will consume energy.
Right.
There also energy.
Correct. Okay, so I am saying that all those calculations are much easier, more visible, versus for petrol or diesel, we don't really do that kind of mathematics. Right. So for coal, we've got a lot of calculations done and in place, but for petrol and diesel, we don't have that kind of mathematics so clear. Right. So my guess is, I don't really have the exact mathematics, that again, see, from a energy efficiency point of view, right, the motor runs at better efficiency compared to an engine, because this is rotary versus that is reciprocating. Correct. So purely from that perspective, the watt hours per kilometer, if I were to convert into calories, the will be slightly better for the electric. Okay, that's my point today. I'm not talking of rupee value now. I'm just looking at energy values now. Anything else on this? Some of you are interested in the energy part, so I don't have the exact mathematics, but at least I can take you towards what my thinking is on that. Okay. Very quickly come to charging. Now, India is, okay, I'll talk about the four-wheelers now, right? I'll touch a little bit about two-wheelers also, but please remember, India is the largest market for electric three-wheelers in the world. Okay, so actually, if you look at just the number of vehicles sold, it's the three-wheelers. So a lot of you would have seen those three-wheelers in Kanpur or most North Indian cities. You don't find them so popular in southern India or western India because of terrain. Correct. So in hilly terrains, these vehicles are a bit underpowered. So you end up having very low speeds on those vehicles, right? Most of the battery chemistry that is being used by electric vehicles, three-wheelers, is lead acid, which is the older technology, but it seems to be kind of working out on the cost economics, because a lot of the lead gets recycled. Almost 99% of lead recycling happens with these batteries. So typically, if the battery costs about 30K, 35K, you get about 10,000 rupees, 15,000 rupees back when you are kind of giving your old battery and replacing it with the new one, right? So all those will work on your standard 5 ampere to 15 ampere sockets, right? As far as four-wheelers are concerned, my forecast is that most of us will prefer the 15 ampere socket. Right, so Tata's did this survey, and after doing a lot of research, finding out consumer insights, whatever, they ended up standardizing on the 15 ampere. So they've launched a long range Nexon now recently, and they are offering you a facility of 3-phase AC charging. Right, so what happens with 15 amperes is you got a single phase, right? With 3-phase, your charging rate doubles. Okay, so roughly the mathematics is this: 230 volts multiplied by 15 amperes is roughly about 3.3 kilowatts. So today what you're doing is you are able to pump in 3 kilowatts of energy into your car, right? With a Nexon kind of vehicle with a battery of 30 kWh, roughly in 10 hours, your car is fully charged with a 3 kilowatt charger, right? With a 7 kW, it will be much faster. The long range Nexon has 40 kWh of battery, correct? So with 40 divided by 7 is how much? 6 hours, thereabouts types. You know, so with 6 hours, you get a full charge. Of course, the charging rate is not linear, right? You end up lowering your charging rate towards the end because there is something called a cell balancing that happens. I will not get into details, but if somebody wants, we can kind of discuss that later, right? So those are typically your AC charging, right? Where your charger is kind of built into the car. So you have an AC, there is a rectification that is happening, it's getting converted to DC, and then it is charging your battery, right? The other thing that is happening is DC charging, where the conversion is happening outside your vehicle, correct? And inside your vehicle, you have a direct DC which is going in. Now, different vehicles have adopted different voltages, right? The older generation of vehicles were all 48 volt DC. 48 volt is considered low voltage architecture. It's considered to be safer. And then you had 72, 90. Now we have touched almost 400, 350, 400 volts. And there is talk of 800 volts also coming in. Now, anyone would like to tell me, why do you think voltages are going north? Why do you think automobile manufacturers are trying to increase voltages in their battery packs? Absolutely. Yeah, because your I square R losses are proportional to the current, right? So whatever heating that happens inside your vehicle while charging, while discharging, whatever it is, tends to be, the currents tend to be lower. So your I square R losses are lower, which is the reason why you also have HVDC transmission in power lines, etc., etc. The same logic is being used with vehicles also. So, but by and large, for two-wheelers, roughly somewhere about 60 to 70 volts is what is kind of, so in two-wheelers, you still have a multiple of 48 volt wala effect, because the old lead acids were all 12 volt batteries. Correct. So jo dimag abhi bhi chal raha hai, it's on multiples of 12. Correct. So you have 48 volts, you have 60 volts, you have 72 volts, etc., etc. In cars, that is not the case. In cars, it typically tends to be a multiple of 100. So currently you've got 300, you've got 400, etc., etc. Right. So DC, that's the same kind of a thing. Now there's one more area which I will not touch too much upon. Okay, before I get that, when it comes to DC, so in AC charging, it's simple. Aapka 15 ampere ka socket hai, that's what kind of fits in. For DC, there is still a lot of flux that is happening in the industry. There are no standards which have been set by the government. But by and large, this is the port which is gaining popularity. Okay, so this is called the, right? So I don't know. Don't ask me what the full form is. I don't know. But CCS2 seems to be kind of becoming the norm for cars. As of now, these chargers are not made. They're kind of being imported. It costs about 15,000-20,000 rupees. But I'm sure as volumes have, you will have entrepreneurs who will come in and start making these chargers, these charging ports, the guns in India. But as of now, they are imported. So there is this is your standard three-phase, like the single phase wala hai, industrial socket. So these are slightly better designed compared to your 15 because इसमें sparking का होता है. But again, it's not a very standard fitment. So some people do it, some people don't do it. Mahindra tried it with their some of their models, but most of us kind of tend to go with 15 ampere normal socket. And there is another technology which is called the CHAdeMO, which is used by the Japanese. So the original ESL chargers with the government of India fitted, they use CHAdeMOs, but CHAdeMOs are not something which seem to be catching on. The Nissan Leaf, which is one of the more popular electric vehicles in the world, uses what is called a CHAdeMO charger. Right? Again, don't ask me what the full form is. So these are about chargers. There's a little bit of thing that I can talk about battery swapping. So a lot of times when people make the transition from petrol to electric, they have this petrol pump mentality, which means that I go to a petrol pump kind of equivalent thing, and like the way I fill petrol in my vehicle, I come out in 2 minutes, 3 minutes, whatever. Now, of course, reality is not always the case. Have any of you tried going to a CNG pump? If you have not, please try it out. It takes half an hour. Okay, आप लाइन में खड़े रहो, वो अंदर डालता है, फिर आप बाहर सारे निकलो, खड़े रहो दूर में, फिर ठीक है. So it's not really such a very seamless kind of an experience, but nevertheless the target is to try to go towards that. So a lot of people thought that swapping will be a good idea, where you just take the old battery pack, remove it, put in a freshly charged battery pack, and you are ready to go. It's kind of okay. So let me share this with you. So Reva is a company which was one of the pioneers in the electric vehicle space, right? They started sometime in the 90s. And the founder of Reva, Chetan Meni, he sold his company to Mahindra and Mahindra. And then he started a swapping company called Sun Mobility, right? And the sad news is that it didn't really catch on, right? And we don't know what the reason is, but I was talking to a guy who was working with the Ahmedabad Municipal Transport Service, and some of the Ashok Leyland buses that are running on the AMTS were tried with this particular technology. They had problems, correct? These are all high current connectors. If your connectors are not fitting well after every swap, right, you have problems of the buses breaking down, etc., etc. So by and large, my feeling is for heavy vehicles, I don't really think battery swapping will happen. Correct. There are practical issues over there. Although I can give you a counter example, there is a Chinese company called NIO, NIO, right? And they have for the taxi fleets in China, they have literally thousands or hundreds of thousands of swaps that have happened already, right? So they are trying, I believe Norway has just started an experiment with swapping. But by and large, I don't really think swapping is going to be a very good solution. It might be a good solution if you own the fleet. Right? Suppose you are a Swiggy kind of a setup and you own your own electric vehicles, then you might just kind of say, okay, vehicle comes in, takes out the battery, goes out. Even there, I have my doubts, because if any of you be to Bangalore, there's a company called Yulu. Any of you use their products? Yulu, YULU? Okay, Bajaj Auto has a share in that company. They own part of that company. Yulu bikes, correct? So what they do is vehicle swapping, which means that instead of swapping the battery, correct, you just take the vehicle, put your old vehicle in the new one. And today what happens is, in scooters, 40% of your vehicle cost for an average scooter is battery. And with a Yulu kind of a vehicle, it's 70%. Correct. So if you have 70% of the vehicle which is kind of being accounted for the battery, it is better, just easier from a consumer point of view to swap the vehicle. So maybe that is also something which might happen in the future. I don't know, but swapping is, you need standards in place. Correct. Till the time that you don't have connector standards to start with, right? I don't really think swapping is kind of, and then you also probably would be very happy if you have a standardized battery. There is a company called Gogoro in Taiwan. So they are trying out swapping in a large way. They've got tie-ups with some of the Japanese manufacturers, but it's still not working. There's a company called Revolt. They have offered free swapping to their customers, but there are not too many takers for that. The battery weighs 22 kg. So try swapping that, right? So, so there are practical issues in swapping, but I'm not writing it off, because I'm on the board of a company whose name is PowerSwap. Right, so we hope that our batteries will get used in swapping. so it will be not fair for me to kind of write off my company's investments, and yeah, we move on. Yeah.
Sir, I have seen your one lecture. In that you have said that in a scooter or something electric scooter, then we can use that battery for at least 10 years. Like for 1 year, if 100 cycles are there, it has 1000 cycles, so we can use it for 10 years, and after that we can also use it for our home inverters.
That's correct.
So there is a condition, or it can do with all the electric vehicle batteries. And the other thing is that if we are after using that in battery also at our home, and after that we replace or give it for the recycling, then there will be a change in the cost.
Yeah, you're right. So again, I'll take part of my presentation, which I'm going to be talking about later, and I'll try to answer your question based on that. So there is, what is happening inside the battery is chemistry, right? In fact, Kanwarji is an expert in that area, so I don't know, maybe I'll bore him a little bit with this, right? So what's happening inside is chemistry, right? So you have a certain reaction that happens during charging. You have the opposite reaction that happens during discharging. Now, these are not reversible. These reactions are not reversible, right? So that irreversibility of the reaction is what causes degradation. You have any reaction, any chemical reaction is a surface area dependent thing, right? Which is why when you have got porous anodes or cathodes, your surface area increases and you get more reaction, right? But at some point of time, because of the irreversibility, your part of your anode or cathode, I don't know what, kind of starts getting covered with these salts. So your reaction doesn't happen over there. Correct. So over the years, for example, 8 years down the line, 30% of my anode or cathode is now covered with salts in my own E2O, which means my range, which used to be 100 kilometers earlier, is now down to 70. Right. And this is what is degradation or range reduction or whatever you want to call it. Right. Now, this is not the same for all chemistries. Right. In some chemistries, the degradation happens faster. In some chemistries, the degradation happens slower. So if you take a LTO kind of chemistry, then the degradation is very slow. So you can actually use that battery for 10,000 cycles. But titanium, it's expensive, right? Then at the other end, you got lead acid, where the degradation is quite fast. In 300 cycles, 400 cycles, you're done. Kahani khatam. So you have to scrap it within a year. Right? Your mobile batteries, for example, NMC होते हैं sir. ठीक है? So you use your mobile, खत्म होता है ना, talk time कम होते जाता है ना, कितने time में कम हो जाता है? 3-4 years, you're lucky, man. You are hardly using your phone. साल 2 साल के अंदर कम होना शुरू हो जाता है. ठीक है? Because typically NMC batteries around 1000 cycles के आसपास में मर जाते हैं. ठीक है? इसमें भी part cycle वाला concept रहता है. So full charge to full discharge is one kind of cycle, right? If you're only doing it at 50%, you probably will get a little bit more, right? So NMC is again the same chemistry which is being used by the likes of Tesla and MG and so many other companies, Aether, right? So they are all using NMC chemistry, nickel, manganese, cobalt, lithium, nickel, manganese, cobalt. Right? Lithium is also there, right? So it will depend on what chemistry you're using. The chemistry I prefer is called lithium ferrophosphate. Correct. And that's the product that my company makes. Correct. So this is a kind of pitch for the company in a way. But more importantly, there is also a safety angle to it. I'll kind of discuss that later on. Right. So yes, for LFP, you can look at about theoretically 3000 cycles. Practically 1.5 to 2000 ho hi jate hain. Right. So you get much better life out of LFP compared to NMC. One. Second, when your vehicle, for example, most automobile companies will define 70% degradation as end of life, which means if your vehicle was giving you 100 kilometers and now it's only giving you 70 kilometers, but technically you can now scrap the battery. Correct. So a company like Tata Motors offers a 8-year warranty on a battery. So what they're saying is that till 8 years, they expect, they have not put this on paper still. Correct. But internal documents, they expect 70% degradation tak ho jayega in 10 years time or 8 years time. So now, for example, if you are a solar energy company, for example, aapke telecom tower lage hue, right? So today what happens, you need energy to run a telecom tower. So you could have seen a lot of these telecom towers have gensets next to them. Raste pe dekha hoga na, you have a genset which is attached to that particular tower. So instead you could have just put up a solar panel, but you need to store energy because raat ko kya karoge, right? You need to run the tower at night. People will not stop using their mobile phone just because there is no, light coming at that point of time. So where do you store the energy? So you store them in stationary packs. Now in a mobile pack, energy density is important because finally, that is determining the weight of your vehicle. Correct. If you use very inefficient packs, then maybe 50% of your vehicle weight is just batteries, which means that you are not transporting human beings, you are only transporting batteries. Right? Whereas in a telecom tower, it doesn't matter. Okay, you may have very bad energy density, but since the battery's got a stationary application, ki farak penda hai. Right? So you end up having a second life for these batteries, typically in stationary applications. So they could be either for home inverters, they could be for telecom, they could be for whatever, non-vehicle. Right? After that, you go look at recycling. Right? So you're extending it by as much as possible. My guess is 15 saal tak chal jana chahiye. A battery should last about 15 years given today's chemistry, manufacturing quality, etc., etc. Beyond that, there will be a problem of recycling. The problem will be less for nickel, manganese, cobalt batteries. Why? Because they're expensive materials. LFP mein problem hoga because iron is cheap and phosphates are cheap. right? So we'll have to kind of look at what happens during those recycling. But if there is anything of value, lithium definitely will continue to have value. So we will need to look at some extraction processes. I'm sorry, we don't really have any great industry working on that right now. Okay, but I hope that your department and others will kind of work on some things which kind of ensure that whatever we are disposing of is not hazardous, and it has some of the kind of costlier materials which have been extracted from that particular battery. Hope that answers your question. Okay. So coming back to chargers, I think we've discussed most of these. So one consumer issue that we've seen in the industry, which I must share with you, is that adoption of electric vehicles, one of the limiting factors has been charging. One, of course, is range, right? But by and large, today you have a lot of vehicles which are giving you a range of around 100 kilometers for two-wheelers and 200 plus kilometers for four-wheelers, which is, I think, a very good Goldilocks sweet spot kind of area. You don't really need more than 200 kilometers. If you get it, great, correct? But from your average driving point of view, I think 200 to 50 kilometers is kind of good enough, right? And for a two-wheeler, 100 kilometers is kind of good enough, right? You will have special applications where some people might want to do intercity travel, ye wo vagara vagara, but you typically take the train or the bus most of the time, right? So range is not so much of an issue nowadays, right? Government has also given subsidy, which makes vehicles a little bit cheaper. The subsidies will end at some point of time, but that also is based on kWh of battery. So the bigger batteries have kind of been cheaper, right? So wo sab fayda hua hai. But charging to some extent is an issue because if you stay in an independent house, charging is not a problem. Aapka khud ka makan hai, correct? You can take your vehicle next to your door, plug point, whatever it is, and start charging over there. In some of the older apartment buildings, jahan pe zyada flats nahi hain, you typically have your meters at one single location, correct? So you can draw wires from there and you can charge, which is what I have done in my house, right? But in the bigger apartments, correct, the meters room is small and the parking is spread over a larger area. So you have one problem over there. The second set of people who have a problem is people who don't have parking. So a lot of us stay in compact houses where parking is on the roadside, correct? And what do you do in such a situation, right? So what a lot of OEMs have done is they have got detachable batteries, correct? So you can actually lift the battery out, take it home, put it for charging, get it back in the morning, etc., etc. Now I'm going to link this with one problem that some of you may have heard of. So most of the fatal accidents involving electric vehicle batteries are happening during this, correct? So you've taken this battery home, you put it for charging, right? And you have a malfunction in your charger or BMS. So it's like a balloon. So you're pumping in energy, correct? The balloon has reached its capacity, but you still keep on pumping energy. What's going to happen? So it explodes, right? Most of the times when it explodes in the open, there's not too much of flammable material around. When it explodes at home, you have bed sheets, you have curtains, and you have human beings, right? All of them are explosive or flammable, correct? And that's when fatalities happen. So it's not really a great idea. I would not really recommend this kind of charging mechanism to any of you, correct? But sometimes economics goes over safety. It's just cheaper to operate electric vehicles. So the customer says, yeah, let me just kind of make that compromise and I will see what happens, right? But again, if ever it comes to a particular thing, I don't know how many of you actually own electric vehicles today? Anyone? No one? Okay, lovely. So I have a universe of potential EV owners over here, right? So my suggestion is, if at all you do end up buying, please insist on LFP, because even if something goes wrong, it will not explode, right? So there's thermal runaway. I'll come to that in my second part of my presentation, but But by and large, when you're doing home charging or when you're looking at battery safety, LFP is the preferred chemistry for Indian conditions. Tesla has started switching over to LFP. Okay, so the new cars, 30% of Tesla sold last year were LFP. Right, so forget Tesla, but even in India, you have a lot of. I asked this question to Bhavish Agarwal, who is the founder of Ola, and I asked him the same question, and he said that they are now also considering LFP. Right, even Ather is considering LFP. This is off the record because they have been in touch with us for some chemistry related issues with LFP. Okay, so can we move on? Right, so this is a very interesting policy. Some of you may have heard of it. It's called FAME, faster adoption of something electric, whatever. Okay, so this has also helped Indian industry because what the government has done over here is they've got localization norms over here. It's correct. So they're giving you a fairly handsome subsidy. It's almost 15,000 rupees per kilowatt hour, subject to a maximum of 40,000 rupees for a two-wheeler. Right. When I bought my Tigor electric in March, I got a 2.5 lakh rupees subsidy on that car. So a 14 lakh car, I paid about 11.5 lakhs. Right. Of course, part of that subsidy is gone now. Right. But I think this was a damn good thing. I benefited from it. But okay. So FAME has helped because some of the price barriers that were there in the mind, suddenly vehicles were cheaper by up to 34,000 rupees almost. Right. So a lot of people started buying electric vehicles. We've seen the same thing happened in Norway. Correct. So Norway saw a very fast adoption of electric vehicles because the government had clear subsidy policies in place. China also had subsidy at one point of time, but Norway is out of subsidy. China is out of subsidy. India also in future will get out of subsidy. But by that time, standards have evolved, customer confidence would have evolved, and things are going to be easier. But one of the good things the government did was they ensured localization norms. Correct, except for battery cells, which no one manufactures in India. Correct. So for the rest, they said, okay, 70% of your value addition has to happen from Indian. So there are shortcuts to this. You can buy child parts, assemble them, and claim that I have assembled in India. So the government has tried to kind of address those things also, right? But again, I will not name companies, but there have been companies which have misused these kind of policies and have made some money. So some of them had come in the newspapers, etc., etc. But again, this is not the time to get into this particular thing. But by and large, I am quite happy that this particular scheme has been introduced. It has helped localization, and that's important from a employment perspective. Because if battery packs are being made in India, if motors are being made in India, correct, it's a damn good thing. But if you're importing them from China, IIT Kanpur has a problem. Right? We need jobs for you guys. Okay, let's move on. Okay, I think by and large, we are kind of done with this part of the presentation. Any questions on overall EV before I shift on to batteries? Can we close this presentation?
Hello, sir.
Yeah.
Sir, you have told that maintenance cost is less in EV.
Oh, there's a, okay. Yeah, go ahead.
So you have told that maintenance cost of EV is less, but my question is, EV generally, when we switch towards EV, it increases weight. If you are talking about Nexon EV and Nexon petrol cars, the weight increased by 200 kg approx, right?
I think it's lesser, but see, depends
no, sir,
on.
Actually, I have seen that petrol vehicle Nexon, the weight is 1200 kg, and Nexon EV is 1400 kg approximately. So my question is, when it runs so higher weight, due to higher weight, it will increase, right? The maintenance cost.
The maintenance cost is more driven by moving parts.
And sir, also because due to higher weight, it will rub tire will rub more, and we have to change the tire in a frequent manner if they increase weight.
Okay, so I'll answer your questions in two parts. One, I would say that when it comes to operating efficiency, I would say EVs can suffer. Any heavier vehicle would suffer, right? So you're right. So if the weight is even 100 kilos more, you will end up having a higher cost, because every time you're climbing, you're taking 100 kilo extra weight. So in that sense, I would agree. But as far as maintenance is concerned, that's more a moving parts thing, right? So a battery doesn't have any moving parts, right? So usually it's not something which kind of accounts for a large maintenance. So you don't even have to change water or whatever jo purane lead acid batteries mein karna padta tha. So they're all sealed batteries and you don't need to worry too much about it. By and large, the thumb rule is, if you really want to do good for the environment, use smaller cars. Which is why one of the reasons I bought a Tigor over a Nexon was because it's a lighter car, and I can see that in a watt hours per kilometer, because I average about 120 watt hours per kilometer, whereas I also drive a Nexon where it's between 120 to 150 because of the higher weight of the car. So by and large, the smaller car you have, the better it is. Ideally, all of us should be driving electric cycles. That's the best kind of, you can go into, and I have 2 electric cycles also. Okay. I think that answers your question. Did I miss out anything?
No, sir. Like you have told that you are supporting smaller things, smaller cars. So what about trucks? If we are moving towards EV only, so what about trucks? Because you are saying Indian IC engine. So here it is a very big challenge, right? You can't insure EV in higher in transports, higher trucks and all.
Well, we already have a lot of EVs in the heavier transport vehicles. They are called trains. So trains have been the oldest electric vehicles. We've been using them for many, many years now. I would say 100-year-old technology, because the first electrification in India happened about 100 years ago in the Bombay-Pune track at least. As far as the other vehicles are concerned, so a lot of people think that it might be the hydrogen fuel cell, which might end up being used by heavier vehicles, because it's more complex, but your advantage is you can pack more energy into the same this thing, right? So that's what is the thinking. But hydrogen fuel cells, I have not seen that technology working commercially or working successfully. There are a few hydrogen based cars in California. Toyota makes a model called the Mirai, I think, which is hydrogen fuel cell. So in hydrogen fuel cell, it's not that you burn hydrogen in your engine. What happens is you are using hydrogen again in a battery, and you're kind of converting that to electricity, and then you have your motor. In any case, your battery can be smaller. The advantage in fuel cell is your storage can happen more. You can pack more energy density. So there is a chance that for trucks and for heavier vehicles, you might end up having fuel cells more than EV batteries directly. So this is just a guess that I'm making about the future.
So yeah, so my question will still remain same. Like if we increase the like larger cars and trucks, so it will not sustain. The maintenance cost will increase due to increased weight. And sir, second question about the emissions, like you have shown CO2 emissions. Have you considered life cycle emissions or only tailpipe emissions?
They would balance out. So a lot of the life cycle emissions for a petrol, when you're looking at building, right? When you look at every other part, it's the same, right? So all that is, so the only thing we need to compare is the engine compared to the battery plus motor, right? So that's the kind of life cycle thing, because everything else is ceteris paribus, everything else remaining equal kind of a thing. So if you want to do that kind of calculation, just focus on these two parts. I have not done that very, very carefully, but maybe you could do that, and then we'd be very happy to kind of see what your calculations have to tell us.
Because the EVs are no tailpipe emissions. It is not like zero emission. It is zero tailpipe emissions. So if we are talking about life cycle, so it is not only CO2 emissions only, it is also human toxicity and all. So what is your take on human toxicity? Like EVs are increasing human toxicity 3 times more, according to that one of the research papers which I have read. So what is your take on these things? And the mining of electric vehicles, like batteries, lithium ion and lead acid. So what is your take on that?
Sorry to disturb you, but we are actually only 10 more minutes. So he'll be here around, and he's here tomorrow as well. So if you have any questions.
Am I audible, sir?
Yeah, you're audible.
Yeah.
We were just kind of saying that there are a lot of ethical questions that you're raising, And
We can continue the
unfortunately,
discussion.
yeah, we may not have too much time to answer all those questions. So can we take it offline later on? Can you send me a mail?
You are here tomorrow as well.
And,
Yeah,
and
yeah,
I-
yes, sir, yes, I will share. But if we are talking about sustainability, because what we are doing, we are moving towards sustainability, and sustainability has three pillars, as we all know. That environment, we will talk about the emissions LCA we will do, and
Okay, we'll take your questions later because we are running short of time, Deepak.
okay, sir,
And,
okay,
please kind of meet up with me if you want to. Yeah.
sure, sir, sure.
Thank you. Bye. Any other questions online?
I think we can take it up at the end after
Yeah.
your second
Okay.
part of.
No, I'm okay. So moving on to batteries now. Okay. So let me start with basic geometry. Right. So batteries come in three form factors. Right. So the most common one, which most of you have seen, is the cylindrical one, which is what goes into your clocks and toys and etc. etc. Right. So that's a very popular form factor, and it's not very good for automotive, but there is a history. So most of you probably don't know this, but Elon Musk didn't start Tesla. Okay. So there was another company, I think Lotus Cars, or I don't know what it was, right? So they're the ones who started Tesla, and what they did was they said, what is available with us? Correct. So that point of time, you had laptop batteries, which used to be that cylindrical cell kind of a thing, right? So they found laptop batteries to be easily accessible and available in enough numbers, right? So they started using laptop batteries to develop a car, right? Not the best of solutions, because the number of batteries, for example, 7,000 batteries or whatever it kind of takes to kind of build up, is not really the best way of kind of building up a battery pack. Correct? Because any system may, the more components you have, the higher the chances of failure, right? But sometimes what happens is you have inefficient standards which still become standards, right? Okay. So we lived with that, or we are still living with that, because Tesla and company still continue to rely on cylindrical batteries. But any of the newer companies that have come in after Tesla don't use those batteries anymore. Correct. So you have the other two batteries which are now kind of becoming popular. So one is the prismatic cell, which looks a little bit like what your lead acid batteries are. Correct. And then you have the pouch cells, which is what my company kind of prefers to work with. So both of these have all three will have certain advantages, disadvantages, right? And now I'm talking mostly about safety now. Correct. So because there's been a lot of people who've been worried about fires and so on and so forth. So I thought I'll kind of spend some time talking to you about a little bit about what I know about battery safety, right? So what happens is that you have a certain venting process. So there are gasification that happens when you have a kind of battery which is kind of being discharged at a very high rate or charged at a very high rate. You have a certain gas formation that happens inside the chemistry, and you need to vent that, right? So in the case of cylindrical cells, somewhere near the top there is a small khadda where kind of there's a valve which kind of opens up and the gases are kind of let out, right? And same way for a pouch, what happens is that it kind of is designed in such a way that there is a weak link, so to say, which kind of opens up when the gas kind of reaches a certain pressure. So this is important, because otherwise these gases can really end up being explosive at a later on stage, right? So you need to vent that out. So I'll not take you in through details of this. Can we move on to the next slide? Right. So this is something which is very specific to pouch cells. If you want, I'll take a minute to kind of explain to you. So in a pouch cell, there is a certain pressure that you need to apply over the cell that reduces the rate of reaction. So okay, I don't need to go into too many details, but since this is okay. Kanwar ji, isko bhi hum skip maar lete hain. Matlab, it's kind of getting too technical for me, and yeah, so I'm just kind of showing this particular thing to you. So we did certain experiments in house. So this is our battery pack, the one which we kind of manufacture, and And this is an aluminum die cast plate, this particular thing on the top, right? So when we machine it, we actually kind of machine it in such a way that it's kind of convex at the bottom, right? So this is to apply uniform pressure across the pouch, right? But this particular pack was overcharged, right, for a very long time. And you can see that that convexity has caused so much of pressure to happen कि वो एक 5 mm thick aluminum plate has kind of gone the reverse. So that's the kind of pressure that is happening when you are kind of overcharging the battery, which is why you're seeing those explosions, etc., etc. You know, the Diwali that happens, kind of firecrackers happens. There's a lot of energy which is kind of, you know, being released in a very short time, right? So one of the reasons why people prefer a prismatic pack over pouch is that it provides space for swelling, right? So there's roughly about like is the PPT says 8 to 10% swelling hota after 500 cycles. So you need that little bit more of space, which a prismatic cell can give you, which a pouch cell you need design which can that particular thing. Yeah. Next one, please. Okay. So basically, let me give you my basic understanding of one of the main things that happens during kind of, you know, a battery failure, right? So like I said, so you have an anode, you have a cathode, right? And you have an electrolyte in between. So the typical happens is here is where your ions are being exchanged, and here is where your through the load your electrons are going in and coming. So that's the basic of any battery pack, right? Now suppose something happens which shorts internally your anode and cathode. What do you think will happen? So the ions, instead of traveling over a longer route, will take the path of least resistance and they will start going in from here to here. Now that could happen because of two reasons. One, you have a foreign object which is inserted in. Correct. For example, in the automotive industry, there is something called as a nail penetration test. So a battery pack is taken and you have a nail physically kind of inserted in and see what happens. Correct. So that's kind of trying to simulate an accident in a way. You know, so the earlier one of the earlier Teslas, there was a piece of metal lying on the road and that scraped the battery and the whole car exploded and was reduced to nothing in about 30 seconds, 1 minute, 2 minutes, whatever. Fortunately, the driver at that car point of time escaped, right? But that's the kind of energy that's stored inside, right? Okay, so that's one way of kind of shorting. And the other is that we talked about, you remember we talked about salt deposition and all that on the anode cathode. So that deposition can be localized and building up in a certain area. Okay, so that localized buildup can actually kind of go across the separator and cause a touching to the other side. Correct. And then you have your standard I square R thing which happens. So current बढ़ते रहता है, और भी बढ़ते रहता है, और भी बढ़ते रहता है, and this is what is a kind of almost like a nuclear reaction. Okay, it's called a thermal runaway. So the rise can be as much as 250 degrees Celsius in 1 minute. Right. So that doesn't really leave you with too much time. Right. Which is why heat management is very important in batteries. Correct. You should not allow that to happen. Right. So these are typically things which are kind of going on inside the pack. And from an engineering perspective, this is really, really critical. Right. So most four-wheelers have got air conditioning systems for the battery, which are given priority over humans. Right. In a two-wheeler, unfortunately, there is no bandwidth for that. So you don't have the space, you don't have the cost, you don't have the budgets for doing these kind of things. So most of the time they are kind of convection cooled by air or not cooled at all, or just have some kind of, you know, yeah, move on. Okay. So typically 80 degrees Celsius is your kind of time when these kind of problems start happening. Now we are still debating internally what happens, right? Because in India, ambient temperatures of 50 degrees Celsius are common now. Correct. So almost every city will experience or has already experienced 50 degrees Celsius at one point of time or the other. And these conditions will get more common in future. So assuming a 10 to 15 degree increase in operating temperature beyond. Correct. So 65 of your internal thing is something which is common. 80 is your danger zone. right? So in that sense, we will really seriously need to kind of look at what will happen in those things. Of course, that does not mean that these kind of things don't happen in cold countries. So you will have cars going up in flame everywhere in the world. It need not necessarily be with ambient of 40, 50, right? But it's still something which is a natural experiment that is happening right now in front of us. कि कौन सी बैटरी जलती है, कौन सी नहीं जलती है. I am in touch with a lot of OEMs thanks to my journalism, right? So the Plug in India part where I kind of host this show on our YouTube channel. So as a result, I end up in private to a lot of company CEOs and senior people and service people. Every company has had fires, correct, in their products, right? There is not a single company that I know of which says कि हमारे गाड़ी में आग नहीं लगी, correct? लगती है, right? But the jury is still out, right? But by and large, again, like I told you, and I'm repeating time and again, LFP, not too many reports, right? I don't know of anyone who has reported a fire happening in LFP. We've taken a battery pack, we've dropped it from 50 feet. We've taken a battery pack, we put a JCB on top of it. Okay, we've taken a battery pack, we've shorted all the cells. नहीं जला अभी तक. ठीक है, थोड़ा सा जला. Let me kind of correct myself. So there was a plastic, right, which is used for kind of housing the pouches. So there was some fire that happened. We changed the material composition of that plastic. We put fire retardant chemicals over there. So that has reduced the intensity further. But by and large, okay, this is something which we need to kind of look after. Okay. I think I already kind of LFP के बारे में already बात कर चुका हूँ मैं. There is so this is something which so when we've not started manufacturing batteries yet, but when you start manufacturing batteries, so you have three components. You got the anode film, you got the cathode film, and you got the separator film. So the separator film is the one which has got the electrolytes inside. So the separator films typically tend to be out of PE or PP, right? And again, if you make this fire retardant, your cell becomes better. Right, so we've not reached this stage yet. As of now, most of our cells are being imported from either Korea or China. Okay, so these are the two main sources for Indian supplies, right? So there are other companies which are making Westinghouse and all those companies are there, but I don't think they account for too much. It's the LGs and the Cattles of the world which we are kind of buying most of our cells from, right? So I don't really know what work they are doing as far as this thing is concerned. These are the different chemistries which are popular in lithium. LFP, NCM or NMC, NCA is by the one which is used by Ola. Okay, Kumarji tells me that this has got a better life compared to NCM, right? The remaining two I am not kind of very clear about, right? Okay. Yeah, so I was talking about safety vent. So even with a prismatic, this is a prismatic cell. So you got this safety vent in over here. So it's like a pressure cooker ka release valve of sorts, kind of, yeah. So this is for your cylindrical cells. So this is the same mechanism for a cylindrical cell. Just can we go back to the previous one, please? Right. So here is one interesting thing. You also have a kind of inbuilt fuse inside the battery, right? So whenever heavy current is being drawn, तो वहाँ पे failure हो जाता है. And I'll tell you specifically what I saw in the Ola. So they use what is called as wire bonding. Okay, so there is a bus bar which is aluminum, and then each of the cells is attached to the bus bar using a thin aluminum wire. Correct. So the moment you have very heavy current that has started being drawn by that cell, that wire melts. So it acts like a fuse of sorts, right? So even Tesla uses that technology, wire bonding ka. So it's just an added safety from a point of view of ensuring that current gets interrupted if in case there's a heavy drawing of current, so that once the battery is out of circuit तो reaction खत्म हो जाता है, ऐसा assume करते हैं. ठीक है, you can skip. Okay, so this is something that yeah, this is just the end. So last two slides remaining now. So this is our BMS. So a lot of the value add in a BMS happens in the software. Okay, so those of you who are from an IT background, you will realize it. And one of the things about automotive software is it needs a lot more testing and validation compared to banking software or any other software that you kind of think about, right? So this is going to be a very interesting area for those of you who have an interest in IT, because the requirement for people who specialize in automotive software is going to increase, right? And you need to really worry about the code that you are writing. So we face a lot of problems with our own software, right? One of the reasons why there has been almost a 6-month delay in our launch is because of the software, right? So this is where our software sits in. Okay, move on, please. And this is our kind of electronics on-off switch. We call it the power distribution unit. So these little things over here, they're called MOSFETs. Okay, so these transistors are MOSFETs, which are basically switches. And the reason we use electronic switches is because the on-off can happen pretty fast. So if you have thermal runaways, rates are very high, then you need to switch off very fast. We are working on alternate designs of using relays, because there are certain customers who are saying, यार हम इतना पैसा देना नहीं चाहते, and MOSFETs are electronic component जहाँ पे availability का problem है. They are very volatile in terms of prices. Okay, so we might be looking at a design where we will end up using relays instead of this thing. So we're still working on that. Okay. So that's about the batteries. So any questions about batteries per se? Or anything else? So we kind of have another 5-10 minutes where we can continue, and then we'll kind of have to vacate this room. Yeah. See, the number of interconnections that you are having is lesser. Correct. So आप series parallel में जो कर रहे हैं वो कम करना पड़ता है ना. So every link is a cause for failure. See, so there is an internal resistance that is happening at every kind of connection that you are making. Right. So that resistance of that connection is something which is also causing heat buildup. Right. So the fewer the interconnections that you are making, the better your product is. Right. So I'll give an example of the pouch batteries that we are using. What we are doing is we are not using anything in parallel at all. So each of the pouches that we have is 30 ampere hours. Correct. So what we do is we put maybe 17, 18 of these pouches in parallel, and that's how our battery pack is done. So when you're doing anything in parallel, you have to do what is called as cell balancing. Correct. So अगर आपकी cell balancing ठीक नहीं हुई है, तो आपका one of your cells is kind of going to create trauma for you in future. And when you have only thing in series, then this problem does not happen. Right. So by and large, the thumb rule is the fewer the cells you have, the better it is. Better design. For example, BYD, they use almost a 1 meter long pouch or prismatic. I don't know. Shayad prismatic ही है वो, but it's 1 meter long. Why do you think they do that? It's called a blade battery. They call it generally the blade battery, because the surface area is more. So cooling is a function of surface area. Correct. So you don't want a spherical battery where the cooling will be the worst. Correct. So you want a form factor where you have a lot of evacuation possibility, the thermal energy evacuation possibility, which is why you kind of prefer that particular form factor. So they push it under the vehicle. So all these 1 meter long batteries, they'll push it under the floor, and then they have more cooling area available between the cells. So that's what they are kind of preferring at this point of time. Yeah. Sure, please. Okay.
I have very general question that I am concerned the way it is exploding, the battery is exploding. I had booked a Ola scooter, but now because I saw that a lot of explosion is happening. So what can you give a realistic sort of assumption or faith among the consumers that why people given the scenario that
Okay, so you're an economics student. Let me ask one simple numbers ka question to you. How many Ola scooters exploded? Can you answer that question?
No, I do not have the.
Can I give you the data? Can I give you the data? One. Now you need to understand. Yeah, this is where. Okay, now Can I take a little bit off track? Right now, where do you get your information from? Most of the time from your conventional media, newspapers, ye wo ya unke websites, right? Now, a Tata Motors or a Bajaj Auto or a TVS spends serious advertising money on media. Correct? They have budgets running into crores. सारे रिपोर्टर के पेट कैसे भरते हैं? क्योंकि वो एड का पैसा आता है, इसलिए वो आर्टिकल लिख सकते हैं. करेक्ट? ओला का एड बजट कितना होता है? 0. They only send on PR. Disclosure, they have spent money on me. They put me up at Hilton. They paid for my airfare. I went and visited their factory. So I'm making all these disclosures to you, so you know that there are biases that I have. Right? But by and large, the way it has been put out is Ola scooter is kind of a bomb. Huh? Not the nice looking bombs that. Correct? Literally a bomb. Correct? What is reality? 30,000 गाड़ी बेचा अभी तक. पिछले फाइनेंशियल ईयर में कितना गाड़ी बेचा है? They are the number 1. Okay, no, at this point of time, number 2. They are the number 2 electric vehicle company in India. Next year, they will be number 1. Correct? So the media is trying to make out a picture. Okay. Did any of you see that Bullet or Pulsar which was on fire? Did you get that WhatsApp video? No. Okay. Please see that. Search for it. You'll find that out also. How many petrol vehicles are catching fires? Does anybody know? Much more than electric. Much more than electric. They've got a bigger installed base also. Nobody puts up videos of electric, petrol scooters or motorcycles catching fire. वो भी देखना चाहिए. You'll stop using Activa now, or Bullet or whatever Pulsar. Okay, so one thing you need to understand is psychology. Okay, all is fair in love and war in electric vehicles. Okay, so my friend, go ahead, take delivery of your Ola. ठीक है, तेरे को अगर इंश्योरेंस पॉलिसी चाहिए तो निकाल ले. शादी हो गई है? हो गई है, ठीक है. 20 बच्चों का फायदा होगा. ठीक है, right? In a scooter, it is very easy to exit. Okay, so it's not that even if your vehicle catches fire or explodes or whatever, you typically have 15 seconds to leave the scooter and run. Correct? ऐसे एकदम खट करके explosion नहीं होता है. There is something called a phase change material that is fitted in batteries. Or phase change material is like wax. Correct? So what a phase change material does in a battery pack is that when there is a kind of local heat generation, तो वो जो मोम है वो गल करके हीट एब्जॉर्ब करती है और फिर बाद में जब ठंडा हो जाता है तो अपने आप वो सॉलिडिफाई हो जाता है. करेक्ट? सो एवरी मोस्ट गुड व्हीकल मेकर्स विल हैव अ फेज चेंज मटेरियल. सो शुरुआत में यू मस्ट हैव सीन ऑफ सम ऑफ दोस वायरल वीडियोस, प्योर ईवी का देखा होगा आपने, तो उसमें पहले धुआं निकलते रहता है और 15-20 सेकंड बाद पटाखे बजते हैं. So that is because the initial part is where your phase change material is picking up the heat, it is evaporating, and by that time you've left. Huh? You don't have to take a mobile and start shooting it right over there. क्या हो रहा है, क्या फट गया, वो सब मत करना. ठीक है? So by and large, I think, and you know, all said and done, any technology will come with its risk. Correct? You fly in a plane, there is a risk. You go by train, there is a risk. You go, the moment you step out of your house, you are at risk. Okay, let me put it, even inside your house, you are at risk. A lot of old people die in the bathroom by not stepping out of their house, right? My dad, for example, died that way. So there is a risk, of course, right? But look at the probability. 30,000 गाड़ी बेचा है, एक जला. You got the odds in your favor, man. Okay, so I wouldn't worry too much. You probably have been taken a little bit by the media, but otherwise, I think there are bugs in the software. Let me tell you, it's not great software. Okay, and in fact, Bhavesh is not a good people's guy. Correct? He's a kind of dictator. He's like one of those Steve Jobs types. Right? Maybe you need that kind of character to kind of drive a company, and I told that to him also when I met him. Right? But okay, let's kind of accept. So there is an attrition problem inside the company, वगैरह kind of thing. But by and large, OTAs में वो लोग they take over there, update डालते रहते हैं software में. So the new version of software has got cruise control in it, for example, which is quite okay. It's also got music, by the way. So you can actually play music on the scooter when you ride it. It's not too bad. I tried it. It's not too bad. Yeah, 36-liter dicky, man. बच्चा डाल सकते हो अंदर. थोड़ा ventilation के लिए जगह छोड़ देना. Beer crate, that was the original design. So the Dutch guys who had designed the scooter said, we need a scooter which can fit a beer crate inside. Cheers. So I think it's not too bad a scooter, right? And it's got 120 kilometers real life range. Tested. I drove it for that range, so I know it works. Right?
Takeaway point is garam lage kood jao. Don't keep sitting on it. Garam lage jump on it.
Okay. I shall not read too much into it. Yeah.
Sir, what are the different voltage levels for EV cars?
300, 400 at this point of time. It will go up, but it will go up.
It will go up. Up to 800, 700.
चले जाएगा, उतना तक चले जाएगा.
So I have one last.
Sure. So we come to the end because Professor has announced this is the last question. So thank you. We all have.
We can have more discussions with it. So there's another thing coming up, right? Battery leasing. So instead of maybe you have heard of this or not. So this concept has come up in US where they don't want you to buy your batteries. You buy your vehicle and you're leasing the battery, and as soon as the battery basically runs out of its life, the leasing company is in charge of replacing the battery and maintaining the battery. So how do you think this system is it going to be a system which we all have to actually step into, or is this?
So I'll tell you a real life story to this. So Mahindra offered its vehicle battery on lease, the Ito. Right around the time I bought my vehicle, this is 2013, they had this option of leasing, where they were charging about 3,000, 4,000 per month kind of a thing for the lease, right? Revolt also offered the leasing option, right? Now, in theory, it's nice because it's de-risking. ठीक है, तो आपके ऊपर कोई problem नहीं है, because see, what is the biggest doubt factor in the whole EV business? It's the battery, right? Because tension की बात वही है, मोटर खराब नहीं होती है. लेकिन battery which accounts for 30-40% of vehicle cost, if it kind of goes bad, correct, or if you just happen to be unlucky and you get the worst battery that ever got made by that company, right, you are in trouble, right? So you need a little bit of, what should I say, assurance, reassurance, insurance, whatever you want to call it, right? So in that sense, the leasing kind of is peace of mind. I think it will make a lot of sense for fleet owners, correct, because finally Swiggy, Zomato, they all want per kilometer pricing. So when they hire you as a operator, they said, यार तेरे को इतना रुपए किलोमीटर का मिलेगा, 5 रुपए, 10 रुपए, 20 रुपए, I don't know, whatever it is. So in their model, this kind of fits in very nicely, because I don't want any झंझट, बाकी सब तुम्हारा, मैं दे रहा हूँ ना पैसा तेरे को, right? So the leasing model will be very appropriate for commercial fleets.
Maybe in the reused EV vehicle also, when you're buying an old EV vehicle and you don't want to buy a vehicle which has an old battery or something, then
you don't know how the battery state is.
Right.
So there is, in fact, that may change with time, because you see, with software, you can actually predict the life of your battery, because there is something called a state of health.
Yes.
Right? So a state of health basically kind of measures कि कितना age गया है उसमें से, and that age is a kind of good surrogate for finding out what the life of the battery is. So, but that has to be programmed in from the battery from day one. You cannot just look at a battery and say, of course, there are thumb rules, like, for example, when I take the vehicle for a test ride, and if I found out what the range is, so I can by and large say कि यार इतना बचा हुआ है गाड़ी में, ठीक है, but ठीक है, मतलब, you know, you can't really be very accurate about it. It's all, so any algorithm which shows you the state of charge of a battery is guesswork. There is no accuracy. या कितने किलोमीटर रह गए distance to empty, correct, because it's just an approximation, right? So I think, but again, going back to this Mahindra E2O case, one fine day during the middle of our ownership, there was a fatka called GST which came in. That was not planned initially. So suddenly your rate, the money that you were paying went up by 18%. तो जहां आप 3000 भर रहे थे, आप 3500 भरना शुरू कर दिया. ठीक है. And Revolt के साथ भी I'll tell you an interesting story. They also sold the batteries on lease. ठीक है. And they sold it with very grandly a plan which said all maintenance covered. Okay. Now later on they realized that this is bad for the company. So they started distinguishing between lease customers and non-lease customers. So non-lease customers would get priority because they are paying for the spare parts. And lease customers को थोड़ा नहीं सर वो part नहीं है, 2 महीने बाद आना, 1 महीने बाद आना. So this is my practical experience of the lease वाला thing, right? But by and large, I would prefer that you lease the whole vehicle. Tension कम रहेगा. ठीक है, instead of just leasing the battery, go one step further and say just lease the whole vehicle. That's kind of much easier for you because you don't like the vehicle, you change it, which is what happens with lease plan or any other those kind of companies. I think that will be much better than just taking a part of it because it's a package deal, na? So if your vehicle is in a bad condition, आपका range कम होगा. For example, your tires are under inflated, you will get a reduction in range, right? If your tires are not having the right kind of tread, then you will again get less range. Okay, so it's kind of better to have it as a package deal rather than just silo out the battery and kind of call it as a separate kind of a thing.
So let's thank Mr. Atul Gopal for giving a wonderful. We are really thankful to you for giving a wonderful talk. I think it cleared most of our doubts regarding electric vehicles, and
There's
he's
one
here.
announcement.
Yeah. Yeah, he's
After
here. He's here tomorrow. So from 2 to 4:30, he'll be there in the sustain.